This is 11.2 permutations. Let's take a look at this graphics. Let's say that you are going to choose from these three different activities. Looks like playing tennis, riding a bicycle, or hitting a baseball. But you're only allowed to choose two of these items or activities to do. So on the right-hand side, the column of the little images, there are different types of permutations of two activities at a time. Notice that there's no repetition in any of these. So with permutations, what's really important to remember is that order matters. Before we get in depth with permutations, what we want to do is have you find the factorial symbol and know what it means. The factorial symbol on the Casio 115 ES calculator is found by using the shift button, and I'll just write a little comment here. And then it is x to the negative 1. So you want to be able to look for these items on that calculator. All right, now let's take a look at this factorial. Factorial, in a sense, is basically just taking the number that they're giving you and multiplying it by decreasing the consecutive or successive numbers. For instance, if you take a look at the very top option here, 1 factorial, it is equal to 1. If you look at 2 factorial, and I'll just rewrite these over here, 2 factorial is equal to 2 times 1, which is 2. If I go to 4 factorial, this is 4 times 3 times 2 times 1, and that is equal to 24. Right, so we're looking for this factorial option. Another thing you need to remember is that if you take 0 factorial, that is equal to 1. When you're using the factorial button in the calculator, what you need to do is place your number first. Then do your shift and x to the negative 1, and that'll give you your factorial symbol. So we will be evaluating factorial expressions. I'm going to show the longhand form of doing this, but you can also use your calculator. So in this case, we have 33 factorial divided by 29 factorial. What this means is I can rewrite as 33 times 32, 31, 30, and instead of writing all the numbers after that, I'm going to stop right here at that 29 factorial. The reason being is that I know I have a 29 factorial in the denominator, and that anything after that would be repeated in the denominator. So what we can do is divide out the 29 factorials, and when you go through and multiply these numbers out, you will get 982,080. Or you can place this directly in the calculator by using the fraction button, placing the number 33, hit shift and x to the negative 1 power to get your factorial symbol. Do an arrow down to get to the denominator, type in 29, shift again, x to the negative 1 to get the factorial, then press equal to evaluate. All right, and then let's take a look at the second option here. Now, if you were to put this in your calculator, sometimes it says error button because it is not able to calculate 108 factorial or some really large number out in your calculator because of the pixels that your calculator uses. So in this case here, we're just going to do it by hand. 108 times 107 times 106. Once again, I'm going to stop when I know my denominator matches the number in the numerator. So 106 factorial. Dividing out the 106 factorial, I'm left with 108 times 107, which will give me 11,556. Make sure you put this in your calculator twice and confirm that you have the same answer. That's the best way to check to make sure you did that correctly. All right, so now let's move on to permutations. And it says permutation of n things taken r at a time. And this is the formula. So you have n PR is equal to, there's that factorial for you, n factorial divided by n minus r factorial. So remember about permutations, order matters. You'll hear me repeat this several times, order matters. All right, so to find this symbol, the symbology of permutations right here in your calculator, what you need to do is type in your number first. Just write the instructions here. So you're going to type in your number first, and then you'll hit your shift button. And then the multiplication button. Once you do the shift and multiplication, it'll give you the P part of the permutation, and then you type in your second number. Then you'll press your equal sign to evaluate that. All right. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? All right, and we have a nice little image at the bottom of the screen here. It says for the first shelf position, you have 7 choices, and then 6 choices left. So if you take a look, if you have 7 books, 1, 2, 3, 4, 5, 6, 7, the first option you have is 7 books to choose from. Once you've selected one book, the book that you'll place in the second position, it decreases that you have 6 books to choose from. So you can see that this is going to give you 7 factorial. So now that you have 7 factorial, you can put this into your calculator and you will find that you have 5,040 ways to arrange the books. So once again, like in the fundamental counting principle 11.1, I made little dashes for each book that I'm placing on the shelf. And then I asked myself, how many ways or how many choices do I have for that first book? After I select the first book, how many do I have available to select from for the second position? All right, let's carefully read this next one. You and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. In how many ways can those offices be filled? So when you think about that, you have to think of how many different people you can choose from. You have you and 19 friends. So that's giving you a total of 20 individuals to choose from. All right, there are 3 offices: CEO, operating manager, and a treasurer. So we have our 3 different offices. Remember, we're going to do N, P, R. The reason why this is a permutation is because you have 3 unique offices. It does matter how those offices are selected. We can't pick one person and say you can be a CEO and the manager at the same time. If once you're taking the CEO position, you are now not available for the next position. All right, so you have 20, permutate 3. In your calculator, you're going to type in 20. Then you'll do the shift and the multiplication symbol for the P, and then type in 3 and then equal afterwards. All right, using our formula though, this is 20 factorial over 20 minus 3 factorial. And that is going to give you 20 factorial over 17 factorial. And once again, you can put these into your calculator. I'm going to show you the handiwork so you know that this is how to set up the problem. Again, we'll stop at 17 factorial because it matches the 17 factorial in the denominator. And when we multiply this out, we're coming up with 6,840 ways to fill the offices. So 20 permutate 3. In this case, when it says how many ways can those offices be filled, the order matters because those are distinct offices. All right, here's another new definition for us: permutations of duplicate items. The number of permutations of n items where p items are identical, q items are identical, r items are identical, and so on, is given by the following formula. So you have n factorial divided by p factorial, q factorial, r factorial, depending on how many unique items you have that are repeated. All right, this will make a little more sense once we go and do a problem. In how many distinct ways can the letters of the word Mississippi be arranged? So what we should do first is count how many letters are in Mississippi. And it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters make up the word Mississippi. So total number of letters, I'm just going to be my n. So that's my numerator, my n factorial. And then I'm going to look at each unique letter. So for the M, that occurs 1 time. The I, it looks like I have 4 I's there. S's, I have 1, 2, 3, 4 S's. And then I'm looking at the P's, and I have 2 of those. All right, so my formula is going to look like 11 factorial divided by, and you can put the 1 factorial or you can leave that off, times 4 factorial, 4 factorial, and 2 factorial. So we're writing down each unique count for each of the letters. All right, and then again, I'm going to work this one by hand. And you don't have to do this. You can put it in your calculator. This is 11 factorial, so I'll do 11 times 10 times 9, 8, 7, 6, 5. And I'm going to stop at this 4 factorial because I notice I have a 4 factorial in the denominator. I actually have 2 of them, but I'm just going to keep 1. The 1 factorial over here is just 1. So I'm going to leave that off. I'll leave the first factorial as is. The second factorial for 4, I'm going to do 4 times 3 times 2 times 1. And then for the 2 factorial, that is 2 times 1. And all of these are getting multiplied. So I'm going to divide out the common 4 factorials. And then I'm going to go and divide out another number here. So I can do perhaps 4 times 2 is 8. And I'll knock out my 8. And then I can also do 3 times 2 is 6 and divide out the 6 in the numerator. Again, most of you will probably just do this in your calculator, and that's not a problem. I just like to show some work. 34,650 distinct ways for these letters to be arranged. So once again, we counted the number of letters in the word Mississippi, and then we looked at each unique letter and counted how many times that letter occurs. The number of times the letter occurs is actually going to be the factorials listed in the denominator. All right, so here's the last problem. It says, how many distinguishable 7-letter words can be formed using the letters in Alabama? All right, so they're telling you that you have 7 letters in Alabama, so N is equal to 7. I'll look at my A's, and I have 1, 2, 3, looks like 4 A's. For L, I only have that occurrence as 1. Each unique letter. B is 1, and M is 1. So the way I would set this up is 7 factorial over 4 factorial, 1 factorial, 1 factorial, and 1 factorial. Again, this represents my A's, my L, my B, and my M. And we know that the 1 factorial, they're all equal to 1. And 1 times 1 times 1 is itself, so I'm going to leave that alone. And I'm just working with 7 factorial, 4 factorial. So 7 times 6 times 5 times 4 factorial divided by 4 factorial. Dividing out the 4 factorials. And that looks like that'll give me 210 distinguishable ways or distinct ways. All right. So 210 distinct ways to create a 7-letter words. And this concludes permutations.